Everybody, I'm Patricia Pavier, the director of the Office of Materials and Chemical Technologies. I think it's the third or fourth time I'm doing that, so it's always a pleasure to be here and to present you the call that we have this year for these NEUPs. So we have been reorganized. We're still kind of trying to find where we fit, but I wanted you to understand where this office is. So as you can see on your screen, now the number is NE43. John Orsek is still our Deputy Assistant Secretary. We have a new Associate Deputy Assistant Secretary, Sal Golub, and we have changed the name. Now it's Nuclear Technology Research and Development. I have two campaigns under my office, which is the Material Recovery and Waste Form Development campaign, and we have also the Material Protection, Accounting and Control Technologies, and it will be presented by Mike Rhyme. You cannot see him, but he's just right there. So you are familiar with the fuel cycle. This is basically a picture showing you the complete fuel cycle. We are focusing really on material recovery, recycling, waste form development, and also off-gas. Off-gas, for me, it's a top priority. Either you choose aqueous or a pyroprocess chemistry, you will have always to deal with the off-gas. So this campaign, we always emphasize on trying to, I will say, improve the current fuel cycle. It's a one-through fuel cycle. We keep in mind that we should close the fuel cycle. Remember, Dr. Walt Wigeland put a very beautiful report, the evaluation and screening study that it's on the INL website. You just put evaluation screening study, where basically over 3,900 fuel cycle options, the best are recycling. So that's the reason we're focusing on recycle. We also try to maintain our US expertise in radiochemistry. Unfortunately, we still see a strong decline. So for me, it's very important to engage university, young students, young professors into this field to maintain our expertise. And I'm happy to say that, over the years with this campaign, I saw the growth, I saw the breadth, I saw the people really engaged. And now we have really reached this international reconnection. And this is extremely important. And it's thanks to you, the university, who are helping us to make this campaign really beautiful. Let's make the fuel cycle great again. So, objective for the major R&D areas. We have one call for the Sigma team for advanced IT9 recovery, one call for the off-gas, one call for advanced waste form, and one call for pyro. You're going to tell me, oh, Patricia, why do you have so little calls? Well, you have to petition and say this is important, the back end of the fuel cycle. The funding we have for the material recovery waste form campaign is decreasing. So consequently, I don't have a lot of funding to put a lot of calls and to reward you. And this is unfortunate. So here you see the first call. The federal point of contact is Stephen Kong, and the technical point of contact is Mark Williamson from Argonne National Laboratory. So this is the call focus on the pyro processes, and I'm going to read that. We need to develop innovative fission product recovery technologies to enable salt recycle, thus minimizing high-level waste production, potentially reducing the cost. So when you do reprocessing, each time you try to minimize the waste that you're going to generate, you try to recycle as much as you want, and you try to think to the cost. How much is it going to cost? And it's really nicely written here. Proposal should address the chemical basis for the recovery process, the fission product elements targeted by the process, expected recovery efficiency, final form of fission product elements for encapsulation in a waste form. Waste form are extremely important. These waste forms will go ultimately in a repository. So I want you to think to a durable waste form. And of course, the waste generation estimate, how much is it going to cost? Processes, and here we give you some example, but sometimes think a little bit out of the box. You're the university. You are free birds. I wish I could be a free bird again. Free birds, you can really think. Give us some new ideas. That's the reason we need you. You're there to give some new blood. We could employ electrochemical, reductive extraction, other techniques, and that's you, other techniques, to recover these fission product elements present as chloride in the electrolyte salt in a form suitable for an encapsulation in a waste form. So that's the first call. Second call, so this is more aqueous reprocessing. For those of you who are engaged in this campaign for a long time, you know about this ALSEP process. This is the actinide lanthanide separation process. If you want, we have an oxide fuel. We're going to dissolve in a nitric acid, hot nitric acid, highly concentrated, 13 molar, and then we're going to extract either uranium technetium or a modified Briggs process, like uranium, plutonium, neptunium. And then we have a raffinate. This raffinate is in an aqueous solution, nitric acid, and we want to recover, for example, americium. This is the ALSEP process. So we have developed this process over several years now, but there's still some uncertainties. And here, this is what I need your help with. Solvent extraction chemistry, radiation chemistry. When you extract something, you're going to create some degradation product. Because of radiolysis, alpha radiolysis, for example, americium, you're going to create radiolysis byproduct. How these radiolysis byproducts are going to impede your process. This is where I need your expertise, trying to find out what are the different degradation paths, what are the different species, how can I clean up my solvent, because when you have an industrial process, you don't want to buy again and again the solvent. You want to recycle. Not only recycle the actinide, recycle also your solvents. So this is the call, and I hope you will be able to help us. The third call, the advanced waste form. So this one is the off-gas. We put here a diagram to, especially for the one who do not know really how a industrial process for recycling is working, to see where is the vessel of gas, where is the dissolver of gas. So we're focusing a lot on iodine. You know that in France, in UK, in Japan, we're recycling. When you look at where are the recycling plants, they are always close to the sea. And there's a reason, because close to the sea, there's the wind, and then you can have off gas. The wind is blowing, and the off gas goes away. For example, France, they go to UK. Yay. Can we do that in the States? No, we cannot. We have very strong regulations, the EPA. So as soon as we will build, hopefully one day in the future, a reprocessing plant, we need to make sure that we capture this off gas. Here, it's focused on the iodine. Iodine 129 has a very long half-life time, million years. So you need to make sure to trap it, encapsulate it, have a good waste form. So this call here is to determine the reaction pathway, the kinetics of the absorption of this iodine on a sorbent, the effect of the temperature, associated vessel of gas constituent, on the reaction pathway, on the kinetics, on the rates should be determined. If you have questions, I encourage you to call Kimberly Gray or to email her, John Vienna, and also Bob Jubin. Bob Jubin, and I have a list at the end of this presentation, is the one you need to talk to. He will help you. The last one, finally, it's on waste form. The federal point of contact is Kimberly Gray, and the technical point of contact is John Vienna from the Pacific Northwest National Laboratory. And we're going to focus on the zeolite formation the thermodynamics, and the kinetics. So the proposals are sought to determine the composition, the temperature, the pH boundaries for the formation of the aluminosilicate zeolite that have been identified to impact borosilicate waste glass corrosion rate and to determine the rate of precipitation as a function of the same parameters. We're really focusing on these waste glass. We have a big group at EPNNL working on the dissolution of waste glass, and this is very important to team up also with university to help us find all these gaps and fill all these gaps. Some advice, because I've been in your shoes, I was a professor. How do you make your proposal successful? Do not write your proposal alone. You need to team up. That's the reason teamwork. You need to be with a national lab. I put at the end all the different emails. This is very important. If you're afraid, if you're shy, if you're new assistant professor, you contact me and I will help you to find who you should talk to. Team up. We are on a train. The train is not starting. We're already, I don't know how to say in English, on march. You know, is running, is there. So you're jumping on the train. And I want you to jump and to go with us. In order to do that, you need to team up with us. What we have done, where we are, and why do we need your expertise. So we are looking forward to partner with you. It's very important to me to have students engaged. So if you want your proposal to be successful, show me that your students are engaged. Show me that you are really part with us on this journey. Here I put some email. I am the director, as you understood. I'm always free to help you make a success of this campaign. Jim Brazy is focusing on aqueous processing. Kimberly Gray, it's waste form of gas. Stephen Kong, electrochemical separation. Then we have the National Lab technical point of contact, Terry Todd for aqueous reprocessing, and all of the campaign, John Vienna for the waste form, Mark Williamson for electrochemical processes, and Bob Jubin for the of gas. With that, thank you very much. Always happy to talk to you and wish you the best.
Attendees, if you have any questions, please go ahead and enter them on the GoToWebinar app on your screen, and we'll address those questions. Thank you. Okay, first question. Can one be leading on both FC 1.3A and B since there are two subscopes?
Yes, yes, of course. Yes.
For FC 1.3A, is capture of iodine the only fission off gas of interest?
Yes, for this call, yes. Very narrow call.
Okay. Would electrochemical methods to clean up solvents be of interest?
Why not? Sure, yes.
We'll wait a few more minutes to see if any more questions come in. Okay, next question. Is the waste form development for salt encapsulation of interest?
Yes, yes, this is what I said, yes. Yes.
The back end of the fuel cycle does not appear to welcome new ideas for more cost-effective solutions. Is this due to the commitment with glassification as the only pathway?
No, that's not true. We don't focus only on the glass wasteform. We have advanced glass wasteform, advanced ceramic wasteform. But you know, like I told you, I'm limited by the numbers. So when my campaign is small, I will have just limited funding for you. That's the reason the scope are very narrow. I would have more money, I would have more call, and we could have calls on advanced ceramic waste form, advanced glass ceramic waste form. But unfortunately, because of the limited funding I have, we are focusing on the glass.
The FC 1.2 call for this year basically describes the exact research that was just funded.
No.
Are you looking for
No,
research in a similar direction?
No, last year it was focused on the kinetics. If you want, you extract the lanthanide and the actinide into an organic phase. Then you strip your actinide into the aqueous phase. And the stripping was very slow. That was the kinetics. That was the call last year. This year, I'm talking about the degradation product. Degradation due to solvent, so you will have solvent degradation product, and due to radiolysis. I'm not talking necessarily about the kinetics. I'm talking how I'm recycling this solvent. How can I identify this radiolysis byproduct that would impede my process? So it's a very different call.
Could you elaborate more on the role of modeling and simulation in the program?
Well. Again, the funding. I had a workshop that was in February with the impact campaign you're going to hear about very soon and the material recovery. I had a big vision to more develop the simulation and modeling. Unfortunately, I'm stuck. We do not have funding. So I do hope in the years to come that DOE and upper management will understand. For the moment, I do not have the funding to pursue modeling and simulation, and I regret that sincerely.
Would zirconium oxides be of interest as advanced waste forms?
No. Thank
you. Is Oak Ridge's Bob Jubin in the contact list the best contact regarding iodine off-gas topic?
Yes, he is.
For FC 1.2, is there a specific solvent to be considered?
Okay, so that's the reason I say you need to partner with us. You need to contact Terry Todd, who will directly to the different people who are working on this campaign. On the top of my head, I'm thinking to Greg Lumeta. For example, we have people also at Argonne National Lab. So you need to contact Terry. He will direct you to the people in the campaign, in the National Lab, engage, and they will explain you exactly where we are and what we need from you to help us.
Okay, for iodine capture and encapsulation, is the primary focus on silver-loaded absorbent? Silver is expensive and not environmentally benign. Any interests on other advanced absorbent?
Show me you can do better. You show me. And if you show me you can do better than what we have now, then you got the proposal funded.
So Patricia, the next question is one that the NEUP office will answer. The question is, last year's call included opportunities for UK collaboration funded by the UK. What is the status and path forward for current UK collaborative work? And the answer to that question, it was answered on Tuesday, is that the DOE is still in contact with the ESPRC, who has funded the UK work in the past. And currently, there are no plans to have UK collaborative work, but that may change as time goes on. If so, an amendment will be made to the FOA to reflect that. And it was just added that they are currently looking at opportunities for FY 2019 as well.
Does the waste form from FC 1.1 have to be glass-based, or could it result in a ceramic waste form?
Yes, could be.